Hello everyone. So in the previous session, we started with the concept of file system. We tried to understand about the file, what are the different kinds of operation, the attributes, and the different types of files are. And we also spoke about the different access methods for a file. And we also spoke about the different directory structure. So in today's session, we are going to talk about file system mounting, file sharing, consistency semantics, and file protection. Okay. So before we go ahead about file system mounting, let's just understand the basic definition of file system. So in computing, file system controls how data is stored and retrieved. Right? So in the initial classes, when I was defining what an operating system is, I always said we always define in simple term operating system is a mediator between the user and the hardware, right? So we know that operating system is a must, but where does file system holds its place, right? File system will help you to control how the data is stored and retrieved. So the controlling of file, right? So operating system has various functions that has to be done, from the initial of rebooting, booting, up to the shutdown of a system. But when you're dealing with the files, okay, which is on the hard disk or the RAM, okay, so the file system controls the data to be stored and retrieved. Okay, so without a file system, data placed in the storage medium could be one large body of data with no way to tell where one piece of data stops and begins. Right. So in the previous session, I just showed you an overview how a file is looks at the top view and how data is basically placed in the hardware. Right. So in the hardware, it is just one huge chunk of data. But if you want the logical view of the file, right? So in that case, basically the file system takes care of it. By separating the data into pieces and giving each piece a name, the data is easily isolated and identified, taking its name from the way paper-based data management system is named. Each group of data is called as a file. So in the secondary storage, it's just a huge chunk of data. But according to, as a user, the data should be in form of files, right? So it should be in form of files, and the file has a unique name to it, and it tell what is the size of the file, and so and so. So the structure and logic rules used to manage the group of data and their names is called as a file system. So file system is basically to control the storage and retrieval of the data from the secondary storage. Okay. So this is how you can visualize where the file system plays. Okay. So each of the operating system can have its own file systems. Okay. We'll discuss about it. Now let's talk about what is file mounting. Okay. Say for example, here I've just showed a single disk. Okay. In this example, the disk is divided into how many drives? You can say it a C drive, D drive, E drive, and F drive. Okay. So this drive is basically divided into, I mean, physically there's one, but logically you can say as if there are 4 drives, and each of the drive can have its own file system. Okay, you can have your own file system such that the data file is stored and retrieved in their own fashion. Okay, so each of the drives, each of the logical drive can have their own file system. Okay, or you can have one file system on the entire drive. Okay, so as long as you don't have the file system being placed, you can't retrieve the data from the disk. Okay, so if you say the data is there on the disk and you retrieve it, but as long as the file system is not mounted, you can't retrieve the data. That is a basic understanding. The file system must be mounted before accessed. Okay, so you should have the mounting is nothing but having your file system being placed on the operating system. Okay, only if it is mounted, you use the word as mounted. Only if you mount the file system, then you can access the drive or the data which is placed on the drive. Single file system can be built out of multiple partition. As I said, you can have one file system for the entire 4 partition. Okay, but let's say if in case you have data in this sector and you want to access the data in data over here in this sector. How can you do it? Okay, what was I'm trying to say, to access, let's say there's a file system over here and a different file system over here. Okay, can I access the data of one file system through an other file system? I mean, through the other sector, I mean, other section of the drive which has a different file system. Yes, you can do it. That is with the help of a mount command. Okay, so mount command, we have parameters to be passed to that command. What are the parameters? First thing is name of the device containing this file system to be mounted. Okay, so just look at the cursor. I'm saying this is the section where I want to mount. Okay, so then what is the name given to this section? Then I say location at the file system to attach. Where do you want, where do I want to attach the content of this file? I want to attach to this section, blue color. Okay, so I'm basically talking about green and blue color. So if you want to do the mounting of this data onto blue color section data, then you make use of the command mount. Okay, mount, what is the name where you want, where you contain the data to be mounted, and the location where you want the system to be attached. Okay, so file mount, mount point, directory at which the mounted file system will be attached. Okay, so a more clear understanding, you can go through this. Okay, so here let's have an understanding saying that the structure of the data or the structure of the directory is in this format in the drive. Okay, what is that? It, you know, slash means root directory. Okay, this is the base directory from the for all the users. Okay, the parent node, you can say. So under it you have a directory called user. Under that you have the let's say file or directory called bill, and also Fred, and under Fred you have something called help. Okay, so this is the directory structure in the disk. Let's say this is the directory structure in the pen drive. So it has Sue, Jane, program, and document. Okay, okay, so this is the structure in the pen drive, and this is the structure in the hard disk. Okay, now both of them have their own file system. Okay, this has a own file system and this has a full file system. Now, can you move the mount? Can you mount this structure onto the file system of the hard disk? Okay, so this is how it is there, and now you want to mount this one over here. Okay, so this is basically unmounted. It is not mounted onto the, right now it is not mounted, but this is how it is there in the pen drive, and you want to move this one to this. You can do it by putting the command mount. Okay, so over here I said mount. What is the first thing? What will be the first parameter? Name of the device containing the file system. So now I want to pass, where is this located in the pen drive? So first will be mount in brackets pen drive, comma, location at the file system to attach. Where do you want to attach? Let's say I want to attach under user. Okay, so if I want to attach this one under user, I mention the location user. Okay, so I pass the command mount brackets pen drive, comma, user. Okay, mounted device should have a valid file system. It means both of them should have a valid file system. A mount table is kept in the kernel which maintains information about the mount point mounted file system. So it's like this, and this system or this portion of the hard drive, I mean this particular hard drive, keeps a table saying that where from which device is the mounting basically happening. So that history is maintained on a table, what we call it as a mount table. Okay, so let's imagine this is from a pen drive, it is mounted over here. Let's say one more other device data or structure is mounted to this. So there could be n device file structure to be mounted. So that is maintained in the mount table. Mount point shall be empty. Subdirectories of the mount point may be hidden. What does it mean? When you're mounting this unmounted portion over here, this can be empty or it can be hidden from the user. Once you move this to this point, the background, I mean this one can be hidden from the user. Okay, to the, I mean it will basically, it will be in the hidden image. Okay, but on the overview you will see as if this is moved to this portion. So after mounting this onto this hard disk, your image would look like something like this. User, and User, under user, you would have this structure. Okay, so you under user, you have Sue, Jane, Prog, and Doc. But in the background, this structure also, this structure could be hidden. That's why it's saying subdirectories of the mount point may be hidden. Okay, so that is about the mount point. Okay, so mount point file system mounting is nothing but you can access the directory structure of one device. Okay, of one device that is attached to the system onto the other drive or device. When I say device, it should be the storage itself. Okay, I can access the directory structure of one storage device onto the by the other storage device, and where both of them have a valid file system. Okay, only thing is you can do it with the help of a mount command. Okay, so that's about file mounting. Next, we talk about file sharing. Okay, so what do you mean by file sharing? One document being created and that is being shared by users. Okay, so if it is a document being created and shared by used by a single user, there's no issue at all. Okay, but what if there are file being shared by multiple user? How do you do it? How do you take the control of sharing that file to multiple users? Sharing a file is desirable when user wants to collaborate. Naturally, when you want multiple users to work on a document or you want to work on a particular a huge program, then you basically have to collaborate. You have to make sure that consistency or the integrity is maintained. Right? So in a multi-user system, more protection and access control needed for file sharing. Right? So basically, you have to take care of giving the protection when you're giving the access, giving the control to access that particular file. Sharing may be done through a protection scheme. So how do I make sure I give protection? Systems use concept of owner and group. Owner is responsible for changing attributes and granting access for a file. Let's say I have created a file, so I am the owner. You can use the word owner or user. Okay, so I am the owner and I have the responsibility, or I have the privilege of saying which all users have what kind of access. Okay, so there's a concept of owner and group. Okay, so what I could do is I say I am a owner, I have my own user ID. Okay, and let's say there are 10 people, and 10 people, there are two category of people. One person, 5 people can read and the other 5 people can write. If that is the case, then I have two groups being set, and I give one group one ID and other group another ID. Okay, so that is what I call it as group ID. Group is a subset of users who can share access to the file. Okay, based on some position of the users, or based on some privilege that has to be given to the users, I group the users who using that particular file. Okay, so user ID and group ID are stored with other attributes in a file. Okay, so if I have 10 users, okay, so those 10 users, what are the privilege that is given for that particular file, and what are the IDs given to that particular groups, that all is stored in the disk. Okay, so user owner ID identify user, allow permission and protection to be per user. Okay, group ID allows users to be in groups, permitting group access rights. So one group given one access means all the people in that group have the same access. Okay, single user access can also be provided. Okay, so this is whatever we spoke about. This is good enough when you're using a local network. Okay, so all people are connected to the local network, and I know who and all are connected to the local network, and I take care of creating groups and giving the particular control. Okay, but what if in case you are making use of a distributed, when you're trying to share files over a network? Okay, so when you're trying to share file over a network, that time the concept of remote file system comes into picture. With advent or with the advent of networks, communication between remote computers is possible. So if I want to access a system somewhere in US or Europe, okay, so there is nothing but remote logging in. Is it possible? Yes. And how can I share a document what is placed in that particular server or that particular storage in that location? Yes. Sharing of resources across the world has become possible. It is possible because of the network. But how do we do it? Okay. One of the very old technique is nothing but FTP. It's nothing but file transfer protocol. Okay, so it's a manual way where basically you have a login credential like putty or something. Okay, you have a basically a login tool for it. Once you log in, you give your credential IP address and you give the remote IP address, and various credentials should be given, and that works over the FTP. That is manual way of accessing a file in a remote place. Okay, then other automatic way of accessing is with the help of a distributed file system. So here what happens? So here in this case, whatever directories are there in the remote machine, those are visible from a local machine. Okay, so that we call it as distributed file system. Okay, so here what happens, you're not, the file is not visible in case of the manual thing. Okay, you through a protocol you access the file and you bring it up to the local system, whereas in automatically you can view, I mean you can basically see what are all the files that are there at the remote location. That is with the help of the distributed file system, DFS. Okay, and one more way of all of us are very much aware of is the World Wide Web. Okay, it's with the help of the browser I access a remote file, and that is somewhat like a semi-automatically way of access. Okay, so when I'm saying I'm sharing a file, is it only with the help of a local network? No, I can share a file which is across the network in a different geographical location with the help of any of the either of these ones mentioned, and there are many much more in the advanced computer network. Okay, just be aware of these things. Okay, now when you're saying you're accessing a remote file through various one of these options, okay, what kind of architecture can you build? Okay, so that can be divided as client server model or the distributed file distributed information system, they call it as DIS. Okay, clear? When I'm saying I'm accessing a remote file, what kind of architecture? Okay, previously when I spoke, these are the kind of protocols or these are the kind of systems that are available, but what architecture can you build? One is called as a client server model. We know what is a client. The system that is requesting is called as a client, and the system that fulfills the request, we call it as a server. Okay, so client server models allows clients to mount remote file system from servers. Okay, so you have a client, single client connecting to multiple servers, or servers can have multiple clients. Okay, so you have that one to many or many to one or n to m connections that are there. Okay, now there, when that kind of architecture is there, you have their own protocol built on the type of operating system you will be using. And some of the commonly used file systems are NFS, if in case of Unix. Okay, see now, listen, this what are we talking about? File system. Previously I spoke about protocol. Okay, when I'm using the client server model, when I'm accessing the data which stored at the remote location, the file system comes into picture even when you're remotely accessing it. Okay, so when you're doing a remote access, it file system could be NFS if it's Unix, or it could be CIFS, that is common internet file system, if it is a Windows operating system which is basically working on. Okay, clear? So this is nothing but when you are doing remote file system, you can do it either by a client server model, where the you make use based on the type of the operating system, NFS or the CIFS is used. Okay, or other model is the distributed information system, right? So what happened to make client server system easier to manage? Okay, so in case of client and server, each client is connecting to the server. So when that request is sent and the request is being sent by one to many, right? For this this to be made more easier, they come up with a distributed information system. They also call it as distributed naming services. So what does this provide? It provides unified access to the information needed for remote computing. So it's like somewhere you have a let's say you have heard about yellow pages with respect to telephone directory, right? So telephone directory yellow pages is what you have: the names, sorry, you have which country, which city, which district, and you have the names and you have the phone numbers, right? It's the kind of giving you a index. So here also it provides a unified access to the information needed for remote computing. If you want to connect to the remote system, it gives you a easy access of what are all remote systems are there and what is the easy way to access it, right? And that can be provided with the help of the DNS. You've heard about domain name system, right? So that provides host name to network address translation for the entire network, right? So you, let's say you say www.google.com, right? So google.com is according to my understanding, but how does the network understand that google.com? It's with the help of the IP address that is maintained by the Google. Okay, and to which system, to which server your local system is connecting, that IP address is being monitored by the network, right? So that host name to network address translation is taken care by the DNS. Okay, so in that system, the various protocol that can be used, such as LDAP, it's nothing but lightweight directory access protocol, and the distributed network system, distributed network information system, active directory implementation, and so and so. So you just understand a simplified uh, way of accessing the remote file system can be done with the help of a distributed information system than compared to a client server model. Okay. So this is about file sharing. Okay. So we just talked about, can a file be shared? Yes. And which all ways can it be shared? Is it only locally, or if remotely, which are the possible ways? Next, we'll talk about, when I am sharing a file, do we really come across the different kinds of failures, right? Yes, we do come across the, I mean, for sure, when I am sharing the files, we would come across some kind of failures, right? Local file system failed due to failure of disk, corruption of directory structure, disk control failure, and etc. Right? So when I say I'm sharing a file, there could be a failure. Why? Either your disk got corrupted where your file was there, or the structure in which you had saved that file, the directory structure got corrupted, or the disk control itself failed, right? The controller is nothing but between the hard disk and the your operating system or the RAM, there's a controller which helps the flow of data to and fro. So that controller itself got failed, right? Errors caused by the user or system administrator can also cause files to be lost or directories to be deleted by mistake. By some kind of manual error, there could be a possible that the file got deleted. So these are a kind of failures that could happen locally, right? So it could be a manual deletion, or it could be some hardware failures which lead to a local file system failure, right? But how about in the case of a remote file system? Can, when you're accessing file in a remote area, could there be a possibility of a failure? Yes. What are the kind of failures you could have? Either there was a network failure, right? You're accessing with the help of a network. There could be a failure in the network, or there could be a failure in the server itself. The server would have been hung, or there's some problem with the server, right? So there could be a failure either at the network or at the server level. Let's say our local is good, working fine, but there could be an issue at the connecting end or at the end of the server, at the server end. Interruption of network can be due to hardware failure, poor hardware configuration, or network implementation issue. So when I talk the word network, network itself is a huge topic to talk about. And to maintain a network to work all good and fine itself is it's a task by itself, right? So if you don't have a good configuration, and the network is not maintained such that if one network goes down, an alternate is being picked up, right? So if that and all is not taken care, naturally when you're trying to access a remote file, there could be a failure. Okay, so when you're accessing this file remotely, what could have happened? What is a situation you could think about? Say a client is using a remote file system. Client may be opening, reading, writing, closing files. Okay, I at the client, I'm accessing the server and I'm doing some kind of operation, either one of them. Okay, suddenly if the server crashes or shuts down, the client has to terminate or to wait. Okay, so I'm a receiver, I'm basically a client, right? So I am doing operation, but at the server end, it got clashed. So what is that I as a client should do? Should I terminate it or should I wait until the server comes up? How do I take the decision, right? So if I terminate all of the sudden, what and all I have been doing can be lost. I should redo it. Whatever I would have task I've done before the server went down, all the thing has to be redone, right? Or do I wait such that the server comes up and then my further execution happens? Termination can result in losing data. Most protocols allow delaying of the operation so that the remote host becomes available again, right? So it depends upon different kinds of network. Okay, I terminate so that I restart from the beginning, or I wait such that the network, I mean the server comes up and my requests are fulfilled. Okay, what are the ways you can do it? Recovery from failure can invoke state information being maintained in the client and the server. Right? So you can think this as a solution. One is whatever request the client is sending and whatever request the server is fulfilling, if all that information, when I say information, that request information and the response information is saved at the client and the server end. Okay, so the client will know, okay, this particular information had been asked and the response is fulfilled. Okay, so if that information or the state information, that's what they say, state information at both end are being saved. Okay, when the information is saved, then both of the ends, the client and the server, know what, where they are basically stopped, where they have basically stopped, so that they could go ahead from that point. They need not restart from the beginning. So that information, state information, will help you to recover from where you had stopped. Okay, recover from the failure. Or there's one more way of implementing that, they call it as NFS implements a stateless DFS. NFS is nothing but network file system and DFS is distributed file system. They use the word stateless. So what do you mean by stateless? Here I told state information. Here what happens, the history in this case, in the network file system or the distributed file system, previously we just spoke about, in this case, this information or the history is not maintained. Okay, the history of what and all happened between the client and the server is not maintained. Only what request, current request, what is being done by the client and what response had to be given. So that we call it as a stateless. Okay, so includes all information in each request, allowing easy recover but less security, right? So the previous history of what the client had asked and what the server had given, that and all is removed, is not saved. Only the current request information is being maintained in that particular session. Okay, but here they say the security is less because they could be forged read and write. They could be an illegal or a third man theft happening, saying this is what the information was asked by the server, please provide me, and that could be a kind of there could be an issue in the security, right? So there could be an illegal request being asked by a illegal third party, um, so that there could be a the forged read and write could happen. Okay, so this is stateful, we can say, and this you can call it as stateless. So here these two methods are kind of solution, like when you're doing a remote file access, how you can maintain, saying that this was my request and I want to proceed from this particular state. So these could be few of the solution that can be provided for a remote access file system access. Okay, so this is about the failure modes. Okay, so we're talking about file sharing. If in case there's a failure, how do we try to resolve it? Next, we move on to the topic consistency semantics. Okay, what do you mean by consistency semantic? Right now, before we spoke about sharing a file. Okay, but now we talk about consistency semantics, which means specifying how many multiple users are to access a shared file simultaneously. Okay, it specifies how multiple users are to access a shared file simultaneously. It's kind of specifying how multiple users are to access. You kind of put a constraint saying that how you can access the file. Okay, multiple specifies when modification of data by one users can be seen by other users. Okay, see here, we're just not talking about file sharing. Apart from sharing the file, there's naturally privilege given to the owner to do some changes on the file, right? So a file user can do some changes. Now when the user or the owner does the changes, how do you want the people at the other end to look at the file? Do you want the changes to be seen immediately, or do you want the changes to be seen by the other users only after you close the file? Or do you want the other users to see the changes only after a particular session? All those things has to be answered or has to be taken care. Okay, so that is what we call it as consistency semantics. Okay, it specifies when modification of data by one user will be seen by the other user. Okay, so here the concept of file session comes into picture. A file session is a series of file accesses between an open and close operation. Let's say I do a open. At the end, I do the close. In between, there's so many things I do. I do read, write, and so and so. Okay, so when do I do a read? When do I do a write? What all do I write? So that all the series of access that I do between an open and close operation, that I call it as a file session. Okay, so let's see what on all way can we can maintain the consistency. In what all way can we implement the consistency semantics? Okay, so in Andrew file system, okay, so this is one of the file system. In this file system, let's see how the semantics is maintained. Writes to an open file by a user are not visible immediately to the other users that have the same file open. Let's say I have opened the file and I'm doing some changes because I am the owner. Let's say there are 5 people who have the same file open, and one person have not opened that file, but he has just in the read access. Okay, now what happens when I do the changes? Will all those 5 people be able to see the change? Yes or no? How is it in the case of Andrew file system? Once the let's write to okay, now I'm writing it. Okay, once a file is closed, the changes made to it are visible only in the session started later. So it means when I do the change, those 5 people who have the same file open, they will not see the change. Only when they close and open the file. Okay, I spoke about the 6th person, right? When the 6th person open the file newly, then he will see the new changes. So it means already open instances do not reflect these changes. Whatever change I do in my file, those changes will not be seen immediately. It is visible only if you close and you open a session only after I do the changes. Writes only visible to sessions starting after the file is closed. After I close my file, then whoever opens that file, that changes will be seen. That is how semantics is maintained in the case of Andrew file system. Let's see in Unix semantics. Writes to an open is visible immediately to other users whoever have this file open. File has a single image that interleaves all operations regardless of their origin. So in Unix, okay, so in Unix, the changes are seen immediately. If there are 5 people seeing my changes, immediately whatever I write will be seen on the 5 users access. Okay, that is how in the Unix consistency of semantics has been taken care. There's one more way that is called as immutable shared file semantics. In this case, once a file is declared as shared by its creator, it cannot be modified. The content of an immutable file cannot be altered. The file are read-only. It means Once it is given as a immutable shared file, it means there's no way you can do the changes. And so since it's a read-only access, no changes are done at all. Okay. So what is that? We just spoke about when you're sharing a file, right? How do we share a file? Then what are the different kinds of failures we could come across? And when you're doing some changes, is it immediately seen or is it seen only after you close the file? So these are the different ways how the consistency semantics is taken care. Okay. Andrew file system is a different. In Unix, it's different. And if the file is maintained as immutable shared file, then it is only basically a read-only file. Once a file is declared as shared by a creator, it cannot be modified. There's only reader. Okay. Next, we move on to the last topic, which is basically protection. Okay. So sharing file, um, giving the control, all those things we spoke, saying that I could be the user and they could be group IDs and so on. So, but when I say there's a group ID, how do I give the access? How do I assign the read and write and execute access? To keep files safe from physical damage and from improper access. So when I say protection, it could be protection from damage and from access, both of them. So that is nothing but reliability and protection. Reliability is what? How do I protect so that my data in the hard disk is never lost? One is have a duplicate copy of files. That's nothing but take a backup. Regularly keep a backup of all the files you have onto a tape drive. Okay, so that is way of how you can maintain your data reliability, reliable. Sorry. Okay. Now, how do you take care of access control? Right? File owner creator should be able to control what can be done on a file by whom. Okay. I should give the access saying that so and so person can have the right access or execute access or so and so. Right. So that is what we call it as access control. Okay. So what are the different kinds of control I can give on to a different user after creating a file? I can give read, write, execute, append, delete, list, rename, copy, and so on. So the various things that that operation that can be performed on a file. So how do I give that control to that particular user? Okay, so these are the different kinds of access that I can give onto a file. So that is maintained in a list, what we call it as a access control list. Okay. Associate with each file and directory an access control list, right? So each file has a list saying that if 10 people are using that file, what and all control do they have on that particular file? Maintain that in a list. Let's say there is a directory, what and all who and all have the access to that directory, what and all control do they have on that directory. So you maintained a access control list, that is nothing but ACL. What is ACL? Access control list to each file or a directory. ACL has usernames and types of access allowed for each user. When a user requests access to the particular file, the access list is checked. Okay, so when let's say there are 5 users, right? So 5 users, when they try to access that file what I had created, you will see whether that user has the access to read, whether the second user has the access to append, the third user has the access to copy. Only if that privilege is given to that user, then he can do it. So where are you storing this information? You're storing it in it's like a table. A table is maintained for each file saying that what are all access are given to the different users who are accessing that file. That's all. If the user is not, if the user is listed for that particular access, access is allowed, else the user is denied. Let's say the first person has only read access. If he tries to alter the file, then it will say access is denied. If you'll remember in the class, I had showed you read, write, execute. If a person is given read access, if he tries to do some changing, it will say write denied or read only file, it will say, right? So that is taken care by access control list. If you look at this example, there are various division: finance, reviewers, managers, clerks, admins. Different groups have different kinds of access. So administrator, you can see all the access he has. Whereas let's say the admin, again he has all the access. Let's say the clerk has only modify, view and view. Over here these three are checked. Okay, so this is just to show what and all access are there and what and all access can be given to certain set of group. Okay, so reviewers has only what? View purpose. See, if you see reviewers, only view, there is no other modification access at all. Okay, by having this kind of access control list, do you think it's helpful? If I have 10 file, then there should be 10 ACL that has been created. So as the length increases, the number of files increases, the number of ACL also will be increasing, right? So the problem with the ACL is, as the length of the list increases, then the length, as the files increases, the ACL also will increase. Need to know in advance the list of users in the system. What is that? If I want to give access to people, then I need to know who are all the users. If there are 100 users, I need to know the details of the users, right? And directory entry must be of variable size. A directory size can't be limited, because if I'm using a directory to have large number of files, then that the size of the directory should be variable, right? So there could be lots of problem when you are giving this, having this ACL for each of the file or a directory. So what could be the solution? So solution could be a condensed access control list with user categories. So they're telling, instead of giving ACL to each file, you have a condensed version of ACL, and that they call it as condensed ACL. In condensed ACL, they have something called owner, group and universal. So you divide the users into groups. Who is the owner, who is the group, and universal means everybody, right? So when you have it divided in that way, then giving the access to that particular file will be easier. You can say this file is being accessed, having read write only to the user, or this file has read write execute access for the group people or everybody. Okay, so when you have, instead of having ACL for each file and directory, you have the condensed version by creating the groups of people such as owner, group or universal. Okay, so by having the users being categorized, then it's easy to share the file. Not only share and give the access control to the file. Okay, how is it implemented? Some examples in Solaris. Okay, in Solaris is nothing but a in cloud and all those places we make use of the Solaris operating system, right? In Solaris, combination of both. By default, the three categories of access is allowed. Three categories is this. And for specific files and directories, more fine-grained access control is allowed. So in this, what happens? Combination of both access control list and condensed control list is used. Means you also have people being grouped, and you also have specific file to be, let's say that's very crucial or very critical file which is not to be shared. In that case, you have a ACL for that file also, that file or a directory. Okay, so it combines both of them in case of Solaris. How is it in Unix? In Unix, directory file and uh, in Unix, directory and the file protection are handled similarly. Each file has um, three categories, okay, such as users, group and others. Each file has 3 bits: read, write, execute. Okay, so there are around 10 bits to take care of this owner, group and others. Others is nothing but universal. Okay, so let's say I have owner, I've given it a 7, 3 bits to denote the number. 111 means what? I have read, write, execute actions for the owner. Let's say for group, I've given it a 6. It means what? I have given read and write access for group. If I've given 1 for public, it means I have given execute for public. Okay. So if you'll remember in the class I showed you, after listing the files within the directory, you could see this, right? What is this? Read, write, dash, hyphen, read, write, hyphen, read, write, write. It means what? So this particular file, intro.ps, okay, it is a file first is dash, right? So it is a file. It has read and write access for owner. It has read and write access for group, and has only read access for the public. So first, these three are for owner, next three are for group, and the last three are for public. Okay. Look at this one. It's a D. D means for directory. Directory is also file, but it is a special type of file, right? So what is the name of the directory? Private. What kind of privilege are you giving for this directory? Does everybody has access? No, it has read, write, execute access only for the owner and no access for other people. Okay, you won't give you no access for group and public. It is only for the owner. So this is how you specify. There are commands like change mode. In Unix, there are commands like change mode, okay, where you can give the access to the file or the directory. Okay, if I give change mode 777 means what? All access for users, all access for group, all access for others. Okay, so you can see. Okay, so this is for time and this is the size. This could be the owner, or sorry, user, and this could be the owner. Sorry. This is the user and this is the group, staff group, student group, and so and so. Okay, and faculty and so and so. Okay, so D for directory, first hyphen means it is file. Okay, so you can give the access. So this is how you will give the access control in the case of Unix. So if you look into this, you can check in your system also. See, there is one user by guest. Okay, so guest, how do I take care of giving the control? See over here, full control, modify, read and execute, read, write, special permission, right? So here I'm saying deny. It means what? I'm denying all these permission to that particular guest. Okay, so if I give a tick mark over here, it means give full control. Okay, so you can do the control, you can take care of giving the access by going to the security tab onto your in the control environment. If you environmental variable, if you go and see in your system, you have this tab, and there you can look at various users who are logging into that system, and you can do the changes itself here. In this is in case of Windows. Previously, this is case of Unix. Okay. What are the other ways you can give the protection? You can give password. Associate password with each file. Password to be chosen randomly and often and changed often. User may have to remember a number of passwords. If only one password is used for all files, what will happen? Once it is discovered, all the files can be accessible. Some system allow user to associate password with a subdirectory, right? One way is to give a password, but if you give each file one password, what will happen? You have to remember n number of password, and that is a very tedious task. If you give one password for all the file, there could be a problem of forgery. There could be a theft that could happen, right? So you should be careful when you're associating a file protection with a password. Okay, so these are the different ways you can basically give protection for a file. Okay, right. So in today's session, we went through the concept of file mounting, right, and file sharing, and what are the concepts when there is a failure when you're doing a file sharing. And we went through the concept of consistency semantics, right, the read and the write mode. And we went through the concept of protecting a file from the read, write, and the different kinds of access that can be provided based on the different kinds of approaches we can take. Okay, so we end the session. Thank you.